Okay, this will be our last class on the mathematics of finances, and it will behoove you to know way more, as much as you can, about these animals called annuities, because most of your life your financial matters are going to come as monthly payments. This series of payments is typically summarized in what we call, I showed you last time, an amortization table. Look at all, it goes on and on and on and on. Could go on for, well, for a home, typically people borrow money for 30 years. So that's 30 times 12, 360 lines of payments. And then finally, when you get down to the end, 30 years later, you can see that your payments stayed the same.
This game changes minute by minute. It certainly does.
But the principal and interest are always changing. The principal is increasing, and the interest, hopefully for your sake, is decreasing. And of course, the balance, the amount you owe, is decreasing all the way down to zero, and then you own either your home or your car or whatever. And get the idea for an amortization table.
Prepare to be astonished.
Now, I really want you to know the idea of how to use an amortization table intimately, because you're going to be using them a lot, I think. So what I'm going to do is actually create one for you right now in a spreadsheet software called MS Excel. Now, I don't expect you to be able to create it the way I do. But my thought is, if you watch me create it from scratch, you'll understand the parts much better. And then we're going to do a little demo with that nice little table, and you'll see hopefully some strategies for paying off loans earlier. Okay? Okay. I've started a spreadsheet here. I've basically typed in all the text type stuff, and now we're going to fill in the numbers. And hopefully you understand kind of what I'm doing here. In this demonstration, I'm going to try to build a mortgage table, an amortization table, for a home loan. We're going to say, just so we have a number, that we're going to get that loan at 7%. So I'll type that in and hit enter. We're going to borrow $200,000. Hopefully we can get a real nice townhouse for that at least. Okay, and I'm going to have this annuity run over 30 years, because that's typically what a home loan goes. It could go for less, 15, 20, sometimes more, but generally they go for 30 years. And we're going to begin this loan on January 1st, 2007. Neato torpedo. Excel actually comes with a function, a built-in function, to calculate the payment. Now you know there's a formula for that, but it actually comes with that. And it's on this little button called the function wizard. And I'll click that to figure out the payment. Well, let's see. Let's go to financial function. It's already on there. And go to, I happen to know it's the PMT function. And I'll click OK. And it has to ask me some questions. They call the arguments. What is the rate for this annuity? Well, this little picture here is supposed to be, it is a button, it's supposed to be a picture of the spreadsheet, so that if I click on it, it actually jumps me to the spreadsheet. Now why would it do that? Well, it's waiting for me to point to the rate. So I'll click on that, and I will in fact point to the rate, which I know is right here at 7%. Okay? Now the picture changed to a picture of the function wizard. Doesn't it look like a little white box with the cursor, which really isn't red? So if I click on that, it'll jump me back, and there I am. Okay, now this is the interest rate annually. We know from the formula that we want the interest rate per period, so we'll have to divide by 12. Okay, now what's the number of periods? That's the n per, and I'll click on that to do that. Click on that. The number of periods, well, is it 30? Well, that's the number of years. Let me click to go back to the function wizard, and what do I have to do to the number of years? Well, there's 12 months for every year, so I'll multiply times 12 and put that in. Okay, the last question it really has to have, the other questions it doesn't have to have, that's why these are bolded, is what is the present value that you want to borrow for this annuity? And I'll click on it to point to it because I put it in the spreadsheet already. And that, as we know, is $200,000. And I'll come back and I'll, as it tells me, my payment negative to me, and I don't want to confuse you, so you know I'm going to change that to a positive, but that's the deal. I think I'm going to change this to a negative of a negative, and we'll know the payment. Every month I'm going to have to pay for this $200,000 home. I'm going to have to pay $1,330.60. It calculated it for me just that fast. How cool is that? Now I've got some really bad news for you. Of that monthly payment, $1,330.60, very little is going to go against your balance that you owe, at least for the first couple of months. You know why? Because you owe interest. And you know, you owe interest on $200,000. That's a lot of money. So let's calculate that interest that we're going to owe just this month. Well, it equals 7%. Well, that's not exactly true. 7% is what you owe per year. We only owe 1/12 of that for this month. So 1/12 of the interest rate, which is 7%, times that $200,000 times the principal. And if I hit enter, it'll calculate, and I'll find out a very ugly fact is that of my $1,330.60, close to $1,200 of that is going against interest. That's very bad news. Let's see how much is going towards principal, because the principal and the interest together make the payment. Well, I'll calculate that by subtracting the payment minus the interest. And you can see the very first month you're only paying, of your $1,330, you're only paying $163.94 in principal. Well, how much are you going to owe next month? Well, we'll subtract the principal from the original principal, the amount of principal that you paid from the original principal. So I'll go equals the $200,000 minus the principal I paid, the $163 I paid that month, which is stored in cell C8. And next month I'll only owe $199,836. Ouch. Well, that's the first month. Now we've got about 29 years and 11 months to go, but the spreadsheet's going to make it easier for us. Try and hang in with me here. Let's figure out what the next payment is for the next month. Well, that's the same, so that's easy. All I have to do is copy this one down to here, and the spreadsheet makes that easy. See the little box down at the bottom corner here? I can drag that down. See how the cursor changes to a plus? Because I'm going to get more. I can drag that down and it'll give me the same payment. So that's nice. Okay? Now, the interest on that payment isn't going to be the same, I hope you appreciate. We're going to pay less interest because we owe less money. We only owe, not that much less, but we only owe $199,800 something. Okay? So once again, let's calculate the interest. And that's going to equal 7%, right? Divided by 12, because it's 1/12 of that annual interest. And this time, not times the 200,000, but rather times my outstanding balance. Okay? Now, do you expect that to be more or less? Hopefully you understand. Since you owe less at this point, it's only a month later, you're going to pay less. So our interest only went down $1, but I know what's going to happen with the principal then. The principal is going to be the payment minus, let's point to the interest, B9 minus D9, and the principal is going to go up, isn't it? The interest went down, the principal goes up, and of course the balance that I owe, this principal now is going to go against that balance. So what will I subtract this principal from? I hope you appreciate I'll subtract it from last month's outstanding balance. So that's going to be last month's outstanding balance minus the principal the amount of the payment that is principal that I paid this month. I still haven't even paid off $1,000. I only paid $200 off that. Ouch. Okay, don't go to sleep because we're almost done, actually. You think, geez, we've got 30 more years practically to go, but we don't. The power of this spreadsheet is that it's going to allow me to fill in all the other information since I put it in as a algorithm or formula type thing. Okay? For instance, the dates, we started on an easy date, January 07, so I want to finish, don't I, on, let's see, January 1st, or actually not January 1st, 37, but December 1st, because that, we finished on a December. So what I can do is go all the way down. Let's see. That's a long way. Close to 360, row 368, I think. And look at all the work this spreadsheet's going to do for me. Hang with me. And I'm going to put all the way down to row 368. And I'm going to tell it to fill it in. Edit, fill, series. Go up 1 month at a time for me, spreadsheet, will you? And bang, it filled all those in. Look at that. Holy water. All the way down. And I actually went too far, didn't I? Let me delete that one. Okay, should be finished as of December. Okay, let's come back up to the top. Now, I can use the copy function, the one I showed you before with this little box, to copy all the other ones down. I can copy it down once, or I can also copy it all the way down. Look how powerful this is. Copy it all the way down. That's a lot of payments, isn't it? Way easier to copy than it is to pay, I'll tell you that. Okay, there's all your payments. Let's go back up to the top. And actually, I don't have to do this one row at a time. I can do all these. See, there's only one little box. And copy all that down. And these are all formulas. Remember that my principal increased as my interest decreased. And of course, my balance hopefully decreased. So let's copy all 3 of them down in one big swoop. Look at the power of this spreadsheet. It's doing a lot of number crunching. I'm going to go all the way down, about 360 payments. And look what it ends up. That's my ending balance, about $0. So that looks correct. Okay? Now let's take the elevator up and see. Holy mackerel. All the payments you're going to have to make. Now as we go up, note that the principal is changing as the interest is changing. And of course the balance is changing. All of these numbers are different. And I'll take the elevator all the way to the top. Now let's take another closer look at this table. We'll jump around between the first row and the last row. The first row here, I notice the payment's going to stay the same throughout all the rows. Remember once again that the principal is going to be increasing as the interest is decreasing. And of course the balance will decrease down to 0. Now I'm going to go down to the bottom row. And here it is. And I can see that the payments stayed the same, and that at the last month I'm paying quite a large amount in principal. Okay? Putting it basically back in my own pocket, and a very little amount in interest. I am paying some in interest though, aren't I? And once I've paid everything off, of course, I don't owe any money at all. Okay? Now, since we've gone to the trouble of creating this whole table, I can't resist showing you something that's probably not as much about math as it is about business and common sense. Let's go all the way back up to the top. We're going to do a whole lap here again, all the way up to the top and all the way back down to the bottom, just so you can appreciate how big this is. So that you don't get lost, I'm going to do what you call freeze the frames, which freezes the titles of the columns so you can see what's going on. Now, if we come back down through the whole 30 years of loans, as painful as it may seem, we just keep going. Go through every one of those is a monthly payment. Come all the way back down through that. We remember, there we go, we remember that each payment is $1,330.60. They stay the same, but each payment is made up of a changing amount of principal and interest, isn't it? Till the end, when you get to the outstanding balance of owing nothing. Now, if you've paid off everything and you owe nothing, let's look at the column sums of what we've paid. Now, we know each payment had a portion of principal, a changing portion of principal. Probably doesn't surprise you too much that what does all that principal add up to? I'm going to use the summation key here and show you, of course, that all the principal that you paid over those 360 payments, those 30 years, adds up to, of course, $200,000. That's the amount you owed for the mortgage. You're not surprised at that, but what I'm afraid I have some bad news for you. What you may be surprised at, if we do the same thing to the interest column, let's do a summation of that. You're not going to like this. Do you know over the 30 years that you've paid $279,000 just in interest so that you could own that home? Meaning that if we add those two together, our total payments, of course, it's going to come to the same thing if we add those two together, we do a summation of the total payments. We've really paid $479,000 for what was originally a $200,000 house. That seems a little scary, doesn't it? It seems like very bad news. But it's not that bad. I want you to consider something. It is now 30 years later. And the good news for you is that 30 years later, that $200,000 house, due to inflation, is very likely worth way more than $200,000. Okay? In fact, it may even be worth as much as what you paid for it, the $479,000, or even more. I want to use a fancy term here. I want to use the term equity. You see, what you've done here is fight off inflation. You probably haven't beaten it, but you haven't lost to it either. I want to use the term equity. You equaled it, didn't you? Okay, if you could sell that house for $480,000 or $479,000, which you probably could now 30 years later, you won't have gotten behind, you see. Okay, and that's why people buy homes. That's your investment, is a hedge or a protection against inflation. The alternative is to pay rent, and of course at the end of the 30 years of paying rent, what will you have to speak for? Well, nothing. You won't have anything. You'll have the 30 years of happy times, but that's it. Okay, so consider that, and consider that when you go to start a mortgage, when you go to close the loan, they're going to show you this. They're going to show you, they don't want to hide anything, that you are going to pay way more for that home by the end of that annuity, if you would. Okay? Now let me go right up to the top. And what I want you to see is that these are all formulas. So what if I got a welcoming home gift, or whatever you would call that, and I got a couple of them. And that first month I decided, you know what, I got about $170 total from people, and I could buy a new plant or a new chair or something like that. But let me show you something else you might be able to do. If I take that amount, that first month, that I'm going to say I got $170 total from everybody, and watch what I do up here. I'm going to take that payment and I'm going to say add $170 to it. Just this one time. I'm going to add $170 to it. So 330 plus 170. I'm going to pay $1,500 just this one time. Now, hopefully, I don't think you memorized all the numbers, but you're going to appreciate every one of these numbers now has changed. Every one of them. Pretty cool. And in fact, just that $170, if we go all the way to the end of the loan, and I go way down, it's going to take me a long time and I can't wait, so I'm going to go down. Pretty cool. Do you know what? Actually, you've paid off the loan already. I mean, well, I shouldn't say that. I say if that $170 30 years from now allowed you to not pay the last payment, because look, the balance is already negative as of the second to last payment. So that $170 saved you more than $1,330 by paying it early. Just $170. Well, basically, you made 7% on $170 over 30 years. And we know the power of compounding there. Now let's change that back. And people say, well, I don't have $170. Maybe you do after Christmas or something like that. Okay? What if every month you could come up somehow in your budget with an extra $45? I'm going to say add $45. That's not too much to ask. Look, that's $1,330 plus 45. Now that's only for that one. Let's add it for the others. Plus 45, and the next one, and then wait a minute. I got to copy it down, don't I? Copy it down to all the others. That's only 45 extra more than what you told the mortgage company you would pay them. Okay, maybe you'll get that from some other part of the budget that you subtracted. I had a friend that stopped smoking, and he had an extra $200 every month. Well, that would be way more than this. All I'm asking is an extra $45. And I want you to see what happens. Well, look at our interest. Look at what we owe. We don't owe a negative number. Actually, if you think about it, until we get back up to 0, I hope you appreciate what happened here was, this is the ending balance. That's where your loan ended. Your loan ended 3 years early because you paid $45 a month. Now let's think about that. By paying that $45 extra, just $45 extra every month, I saved myself 3 years worth of mortgage. 3 years worth of mortgage payments. Well, let's see. That's one payment is $1,330 times 3 years, or times 36 months. I saved myself close to $48,000 of payments. Well, that's not exactly true because I did pay some. How much did I actually pay? Let's calculate that. I paid, well, let's see, 36 minus 3, so 33 years worth, 12 months of that $45. So times 45, I actually paid a total of 17, close to $18,000. But by paying that, let's subtract them. One minus the other. Son of a gun. You have actually made $30,000, and that is as free and as tax-free as can be by putting away an extra $45, just $45 a month, if you could somehow come up with that. Even $10 a month would save you a lot. Okay, so this is a great trick when you have any loan, whether it be a car loan or whatever, a home loan especially, of getting yourself way ahead in the long run, and I hope you'll use it.
I'll leave you with this final thought.
Okay, well now it's your turn, and I'm going to give you the formulas. You have to know how to manipulate them and which formula to use. Okay, so go ahead and try the homework.